Okay, so here's the first one in a little series of videos just running through the notes for the unit, MYP4 Unit 1, Quadratics in Motion. So there's all the IB concepts and contexts and things that we introduced at the start of the unit. So if you want to look at those, if you're missing those, you can freeze frame. And there's the list of contents. So there's 7 things on my contents list there, and that will correspond to a video for each of those. So chapter 1 was what is a parabola. So I defined a parabola as a curve followed, for example, by the path of a ball. So any kind of projectile that you throw often or launch often has a path that can be modeled mathematically by a parabola. So there's a simple example, y equals 25 minus x squared. So if you do a table of values, different values of x from -5 to +5, and then you work out what y is according to that rule. So for example, when x is 4, y would be 25 minus 4 squared, which is 25 minus 16, which is 9. So you do that for all the values and get a set of y values, remembering that when you square a number, a minus number, a minus times minus makes a plus. So for example, when you've got -3 here, you've got 25 minus -3 in brackets squared, which is the same as 25 minus 9, which is 16. So you do a graph of that and you get that kind of shape, which is a parabola. And it can be that way round or it can be the other way up. And in fact, that depends on the x squared term. So if it's a minus x squared term, then the parabola looks kind of like a downwards mouth. And if it's a positive x squared term, then it looks like a smiling mouth. So we did a thing where I asked you to try and sketch some curves. So I wanted tables of values for each of those, a range of values of x, calculate the y's according to those rules, and see what the graphs look like. And then depending on the values you got, you wanted to choose your range of x's carefully because you wanted to include a range of x's that would, and y's that would kind of show the key turning point of the curve and where it cuts the axes. So that was y equals x squared, and I chose x from 5 to -5. And then this is y equals 3x squared plus 2x minus 5. And I found, playing about with it, that if I plotted it from x equals 2 to -2, and then took lots of incremental values in between, then I got a good picture of what was happening with the graph and the key points where it cut the axes. So you have to choose your range of x values that you calculate in order to match the situation that you're in with the function that you're given. And as you can see, it's the same basic shape called a parabola, but not necessarily cutting the axes at the same point. So there's another one, y equals -3x squared plus 2x minus 5. And the fact that it was a -3x squared is the thing that's made the curve turn downwards. Then I started talking about one of the properties of parabolas, or parabolae, if you want to argue about the correct plural for that. And that's well, imagine that's a mirror, and imagine these are kind of light rays coming in, and how they would bounce off that as a mirror. So they kind of bounce off so that the angle going in is the same as the angle coming out. And if you do that for all the points, you should find that the reflection rays kind of meet up at a single point. And that's a property of parabolas or parabolae, that they all do that. So parabolae have the property that reflected parallel lines all meet at a focal point. So even if those lines are coming in from a different point or a different source, they all reflect onto a single point. And that's useful, for example, in a satellite dish, because a satellite dish is basically a parabolic antenna. The Danish word for it is parabol, parabolic antenna. So I wrote, this ability to focus is useful, for example, in a satellite dish, which concentrates the signal onto a single point, which then feeds into the receiver box. So the signal comes in from the satellite a long way away, and then it's all focused onto a point there. And then if you see one of these, you'll see it's got a thing called an LNB, a low noise block, but it's a point where all of the signal is focused, and then you'll see that the wire goes back from that thing that's stuck on there into the house and then into the receiver box.